Bohr's model of hydrogen atom. Bohr's postulate states that the first postulate is an electron in an atom revolve around nucleus in a stable orbit without emission of radiant energy. The second postulate is the electron revolve only in those orbits whose angular momentum is integral multiple of h over 2 pi. If we consider an electron of mass m revolve around the nucleus in an orbit of radius r with velocity v, then we can write mvr is equal to nh over 2 pi, which simply means that according to the Bohr's second postulate, the angular momentum is equal to integral multiple of h over 2 pi, where m is the mass of electron, v is the velocity, r is the radius of the orbit, and h is the Planck constant, and n is the number of orbit or the orbit's number where the electron is revolving. Where h is the Planck's constant, the third postulate is when an electron transitions from one orbit to another orbit, then it emits energy in the form of radiation or photon. Let us consider if E1 and EF are the initial and the final energy of the orbiting electron. Let the electron jump from EI to EF, then we can write h nu is equal to EI minus EF, where h is the Planck's constant, nu is the frequency of the radiation, E1 and E2 is the initial and the final energy of the orbit, where EI is greater than EF and h is the Planck constant because the energy of the initial orbit is greater than the energy of the final orbit. And this is how we will define the Bohr's model of hydrogen atom.